You're on mute.
There we go.
Yeah. Hi, Lanik.
Hello, Abhishek.
Hello, everyone. Welcome to this workshop, To the Point by Christopher Bullen. So we are happy to have all of you over here. And
I'm excited.
Along with Chris, we have Lanik with us, who is the Chief Product Officer of BeeGraphy. And today we will jump in with Chris in this workshop. So I hope everyone is ready to have this session.
Awesome. Actually, it'd be interesting to know how many here are architects or interior designers. Just give a thumbs up. Oh, there we go. Awesome. So just to give you a little bit of a background. So I teach here at local university, and I teach in the interior design department. And we're really pushing to be able to use a lot more of the advanced technologies, whether that be AI and parametric design. And BeeGraphy has been my tool of choice just because of how accessible it is. And when I actually am in teaching, I can ask students in to be able to come in and help me be able to, go through a series of problems, for example. And that's what basically, whenever you're working within any of these node editors, you're typically problem solving all the time. And it's a nice way to be able to get them engaged. It's a nice way to be able to work with them. And at the end of the day, they can get something that actually means something for their project or for their design. So what I'm going to do today, if you don't mind, sorry, can I just jump into it, or?
Yeah. So Chris,
did you guys have more to talk?
Yeah, I'll probably give you a quick introduction to our community members over here who are joining the workshop. And and then we can take it off from there. Okay.
Sounds good.
So I'll say Chris is an expert in computational design. He has already introduced himself, like what he's doing. So he has been there at Mount Royal University for over 17 years. And he combines artistic vision with deep mathematical knowledge, which transform how we approach design. And specifically today's workshop, To the Point, will focus on the fundamental of parametric design, as stated by Chris. And we will be breaking down these essential building blocks, how points can be converted to line to surface, and 3D, and how the whole system starts. So Chris will be guiding us through this practical technique, give us insights that can help us in our design process. So without further ado, I think I'll pass it on to Chris. Lanik, do you have anything to add?
No, I think it was a good introduction. So, maybe Chris has anything to add about himself?
No, because I could sit here and talk about me all day. I'd like to get into this.
Okay.
My background actually is I have my degrees in pure and applied math, and I've been in advanced visualizations for a long time, and helped in the development of a lot of the algorithms and so forth that we use today for a lot of the rendering engines. And I've worked with Autodesk a lot in the past, and I've worked in the architectural industry for well over 20 years, and 30. Sorry. It's been a long time. And I've always been interested in new technology. That's been one of the things that I really love to do. So when parametric design came out, and, with Dynamo, with Revit, Grasshopper, and Rhino, and when BeeGraphy came on the stage, awesome. I was thrilled because of the fact that it was so accessible. We already asking all of our students to be able to purchase a ton of software, and I like to be able to have things accessible so they can learn this, and then when they get into a situation where they need to be able to start applying some of this, they're well versed in it. So let's start off here I'm going to start sharing my screen here, and let's talk about what we're going to be doing today. So I'm just going to jump over here and share my first screen. Oh, I encountered I can't share my screen here.
That's it.
Yeah.
Maybe you're not a co-host yet.
Oh, there, I think that went through. Okay, for some reason, there we go. For some reason, it didn't want to accept the first one. So this is kind of what we're going to be talking about today. We're going to start building this up and start getting a little bit more and more complicated with the structure. But we're going to basically start with a simple graph and understanding the data structures and how we can work with the data structures, and then start augmenting it. Then I'm going to take it from what we did within BeeGraphy, and I'm going to take it out into SketchUp, where I'll show you where we actually use this in more of a physical application within another software. And that could be within AutoCAD, it could be within Revit, could be within SketchUp, and so forth. So that's kind of where the guide of this is going to go. So let me just take this off of here for right now. And I've got a blank session of BeeGraphy. If you guys do want to be able to follow along, you guys can follow along. And I'll explain as I'm kind of going exactly what we're going to be doing here and why I choose to be able to use some of the nodes over some of the others, because there's so many different ways to be able to approach a problem. This is primarily going to be just showing, like, especially getting real world feedback, because there's some anomalies. Is that like those, like here, just give a thumbs up. Who here has been using parametric design and using things like Grasshopper and BeeGraphy and so forth? Okay. In computing, you guys all know everything starts, that's a lot. Okay. So we've got starting from 0 as opposed to 1. And when you divide stuff, you always have 1 left over or 1 too many and so forth. So that's a commonality with this. And that's one of the things that I do want to be able to make sure that the students do understand, because interior designers and architects are not necessarily programmers, and I don't expect them to be programmers, but I do expect them to kind of understand a little bit about the functionality of why things are the way they are. So what I'm going to start off with is we're going to be creating this baffled ceiling. And one of the parameters that I need to be able to initially start off with is how wide is that going to be? And instead of just starting to draw with a bunch of points, we're going to be going back and forth between doing lines and interpolations and so forth and subdividing those lines. We're going to start off with just a basic line. So here within BeeGraphy, I'm just going to raise this up here a little bit. If I double click, you obviously know that you can get a shortcut menu, and this is pretty common, right? And then I can start typing in what I want to be able to get. So if I started typing in line, for example, these are all the nodes that I can get with the line. Now I'm going to use this one here that is the direction and the length, starting with the point. So this one here will allow me to be able to specify an overall length. And I'm using this as opposed to doing 2 points and putting 2 points and then connecting with a line, because I can use one slider right away to be able to give me physical dimension for what the width of this is going to be, and I can tell it in what direction. So for my purposes here, and just to make things a little bit clearer as well, in the preview window, what I'm going to do is I'm going to turn off the grid, and I'm also going to turn off the axes. So you can see here, right, in here we've got the x-axis and the y-axis. Not sure how much I should probably go over, like, you know, in terms of navigating with the zoom wheel, with the right mouse button and the left mouse button to be able to view, but I'll do a quick rundown on that. But I am going to come down here just to make things a little bit easier, and I hit this little gear down here. I'm going to turn off the axis, and I'm also going to turn off the grid, so it'll be easier for me to be able to see this. Now, I'm doing this because I still have this little gizmo here, so I know which the x direction and the y and the z direction is. And this right now is kind of going off into space at 10 units in the x, 10 units in the y, 10 units in the z. That's what this vector here is telling me. So let's go ahead and let's make this go along the x-axis, and let's make it 3 meters long. So in order to be able to do that, I need to be able to tell it a direction, and that's what this vector is going to do. So if I double click, and for vectors, x, y, and z, if you just type in what the axis is that you want. So if I type in x, that's going to give me the vector x. If I typed in y, I can get the vector y really quickly, and so forth. So I'll get vector x here, and by default, it's a factor of 10. In this case, all it's looking at is just the direction. So I'm going to click and drag on vector, plug it into vector. So now it's just going in the x direction. And it's going by default at 20 units. I said that I want to be able to work this in meters. So, and actually, when I say meters, I mean millimeters. So I'm going to type in 3,000 for the size here. I'd like to be able to put in 3,000 for the length. Now I can either come and click in here and enter it in manually and have it hard-coded in the node, Or if I double click here, I'm just going to type in 3000, and it's going to allow me to be able to choose from either constant or a range input. So I'm going to choose the range input because I might want to be able to make this a little bit wider and so forth. Plug this into there. This is now 3 meters long. Okay, and I'm just clicking on the zoom extents here. Sorry.
I guess someone forgot to mute themselves.
Okay. So in this, what I'm going to do is for the range input on this one, just so I can make sense of a lot of the stuff here, I'm going to call this one the span. So if I double click here where it says range input, I'm going to type in span. So that's going to be a 3 meter span that these panels are going to go from one side to the next. And I can obviously change that however I want to. By default as well, and it's also a good note to note in here, and this is the same thing with all parametrics, and I think everybody here is pretty familiar with this. If I choose a number between 0 and 1, it automatically puts the bounds for that slider between 0 and 1. If I choose between 1 and 10, it puts it between 1 and 10. Between 1 and 100, like if I above 10, so if I did 12, it's going to be between 0 and 100. So it's good to know that. This is actually going, because it was 3,000 up to 10,000, so it can go 10 meters wide. You can come in here and I can adjust that to whatever I want to. Let's just say I don't want to go over 5 meters. Then I can just adjust the parameters on there, just by flying that out. So we now have what the span is. What I'd like to be able to do here is I would like to be able to put a bunch of points on this span. And this leads us into the first thing with parametric, like when you're dealing with parametric design, is when I subdivide this, I'm talking about subdivision, not points. And that's the important thing. So if I went in here and I double clicked and I started typing in divide, okay? If I go down here, I got all the divisions that I got here, but I've also got this down here, divide by count. So if I click on that, you're going to see that this is going to allow me to be able to take a curve in, and it's going to allow me to be able to put however many divisions that I want within here. By default, it's 4. So if I plug this in, how many points do I have? I have 5 points, right? So there's a discrepancy here because there's 4 divisions, 5 points. Now, one of the things in Grasshopper, you can put expressions into the inputs here where it automatically subtracts one and so forth, but we're going to manually do that here. And that actually might be on the wish list, Lernick, I'm not sure.
Like to insert a formula inside?
Yeah, to put in expressions in here.
Okay.
Okay, there, we put it on the wish list today. So anyways, let's go in and let's modify this because I want to be able to know how many points I have. So if I go in here, I'm going to put in a slider. So if I wanted to be able to put in a slider, I'm double clicking and I'm just going to type in my number here. Let's go in with, I don't know, I'm going to type in 12. Okay, and then I can choose this as either a constant or a range input. Let's go in and put it in as a range input. By default, that's going to go to 100. So if I look in here, minimum 0, maximum 100. And this is going to be my count. So if I plug this into here directly, I now actually have 13 points. I don't have 12, right? So what I'm going to do is I am going to go in here and I'm going to minus 1 from this. So I'm going to go double click. We're going to type in subtract, be able to get a subtraction. And I'm doing this with all the inputs here where I've got this discrepancy. I'll plug the number into here, and then where it says what number is going to be minus, where it says null here, I'm going to click in there, and I'm just going to type 1 and click away. So now you notice in here, I've got 12, but the number that's actually coming out of here is 11. So now actually it's giving me 12 points, but it's giving me 11 divisions. So if I plumb this in here, and if I bring this down to, let's say, 5, there's 5 points, right? So I can actually say, this is going to be the density. I'm just going to call this the density. So I double click on here and I say density. Okay, so at this one, I can increase the density. And there, I'm not going to count each one of them, but I know there's 40 points there, right? And this is allowing me to make sure that this divide is actually giving me the 40 points by subtracting the 1. That makes sense to everybody? And again, if everybody here is already familiar with this, this is just the way that typically it's set up anytime that I use the divide. So now that we have that, this is going to be, let's say, the top of where our baffle is going to be. Now I'm going to do one baffle really, really quickly, and we'll just do a simple sine wave, or actually a cosine wave, along the bottom of this one. But now that I've got this set up, I have all these points, I'd like to be able to move them in the down direction to whatever dimension that I'd like to be able to have them hanging down from the ceiling. So if I go in here, I'm just going to move this density slider over to here. I now, and this is again very similar to how objects are copied within SketchUp as well. Like you actually are moving an object and leaving the original behind. So this is the original. When I go to move it, I'm still having the original there, right? So if I double click here and we go into move, if I click on move, this is going to allow me then to take all of these points and move them in a certain direction. Now, by default, again, this is giving me a default vector of 10, 10, 10 for the X, Y, and the Z direction. This time, it's actually taking that as literal dimensions to be able to displace these points. What I'm going to do is I'm actually going to tell it, because I just want it to go down in the Z direction. So if I double click and type Z, that's going to allow me to be able to give it a direction here. By default, it says 10 units. I'm going to plug that into the vector. But what I'd like to be able to do is I'd like to be able to have this run off of a slider. So now I can double click and get another slider, or I can take this one. So if I click on there and I click, drag, and if I hold down the Alt, and actually shouldn't say that because the newest, I think in the latest one here, this has been kind of fixed. If I click and hold down Alt, I was getting hundreds of copies sometimes. But if you just click on this, hold down Alt, one or press Alt once, you can just drag and be able to make a copy of that slider. So in this one here, let's actually put this to be, let's say 1500. Okay, so this, oh, it's not allowing me to be able to put 1500 because it's only going up to 100 here. So I'm going to put this to be able to allow me to go up to 3 meters. Whoops, let's put that to 3 meters for the maximum here. Now if I type in 1500, I can plumb that into the factor here. So now that's going in the Z direction. But remember what I said. This is the ceiling. I don't want my baffle to go up into the ceiling. I want it to hang down from the ceiling. So I need this to be in the negative direction. But I don't want to be typing in negative 500, negative 1,000. So I'm going to put in a node in between this, which is going to be, I'm just going to call this one drop. Whoops. D-R-O-P. Okay, so that's how much that it's going to drop down. And I'm going to put in an opposite node here. You can put in a negative node, but in here it's called opposite. So if I double click on this and type in opposite, or if you type in negative, how about if I actually type in opposite? There we go. I'm going to get this node right here. And this is just going to negate, give me the opposite of what's coming in. So this is 1,000, makes sense. It's plumbing in negative 1,000. So now I've got that dropping 1,000 or 1 meter down. Sorry, 1,500. How's everyone doing? Is this okay for pace and so forth? Give me a thumbs up. If there's some thumbs down, then I kind of know if I need to be able to kind of slow this down. Awesome, awesome, awesome. Okay, so I did see a couple in there. What we'll do is once we get this basic graph set up, I'm going to open it up to some Q&A. So those that are having some questions, or if there is something that would need to be able to cover again, I can cover it over before we augment this graph. Okay. So for right now, just understanding what we've done, we've created a simple line. On that line, I've populated it with a bunch of points. I've taken those points and I've moved them to a new location. These points here still exist. They exist in this node. This node are the moved points. So there's actually points in here and points in here, and that's going to follow the entire graph down. There still is a line back in the other node that I've chosen. So now that I've got this down, right, and I've got the drop down, what I need to be able to do is I need to be able to now put an oscillation into this. And in order to be able to put an oscillation into this, I need to know how many points do I have here. And the oscillation I'm going to use is cosine. So unfortunately, we're going to have to get into some math. Now, in order to be able to do this, just so everybody understands, I already have an annotate. So if I just bear with me here, I just got to sign in because this will allow me here to be able to draw on the screen. Yeah, continue. Sorry, I didn't think I'd have to log in again or register again on this one here. Nope. Remind me in 30 days. That's fine. There we go. So now what I can do is I can draw on my screen. So if we go in and let's just say, for example, here, I'm just going to give me some space here. Hold on. Let's give me some space here to be able to draw. So everybody here is pretty familiar with what a sine curve looks like, right? So it's going like this. You have to excuse me, I'm drawing with my mouse, right? We understand that this is 0 in the x direction. This, where it crosses the x-axis, is pi, and this is 2 pi, right? So in this case here, if this is going to be the axes right here, right, we got 0 to 2 pi, that's one continuous oscillation. Then it's going to repeat that oscillation again, and so forth. So these numbers here for 0 to 2 pi, these are what I want to be able to start plugging into the cosine in order for me to be able to transpose those points so that from the start up to halfway, they're going to oscillate going up in an arc, and then halfway down to the next one, they're going to oscillate going down or below in an arc. So in order to know this, we got to know the sine formula. So actually, if we go in here and everybody here, whoops, actually, let's undo that. Let's go back to this. The formula is basically cosine. Oh, man. Cosine of x. Okay. So in here, this is what we want to be able to insert the x values into. Now, 2 pi is one complete oscillation. I could put a multiplier on that, which is going to allow it then to be able to change its period so that it can actually double up however many times it's doing it, or slow it down so it's going to do it half an oscillation or a quarter oscillation and so forth. So what we need to be able to do is actually, I need to be able to take whatever value I put in here and multiply it by, now in this case here, what I'm going to do is I'm just going to put in a p for the period, right? So that's how many cycles that we're going to end up having. Now that's one parameter that we need to be able to work on, and you'll see this in action here in just a bit. The other one is the amplitude. So that's this one right here. I need to take a number and I need to multiply it, some number times the cosine of the whatever the cycle is in 2 pi in this case, and then the period. That's going to give me how high or how deep these oscillations are going to be. So this is going to tell me how high the highest point and how low the lowest point is going to be. That's the amplitude. This is going to tell me how many times is it actually going to cycle through there. So knowing all of that, if we go back to there and then go back to this graph here, what I'd like to be able to do is I would like to be able to create a series of points that goes from 0 to 2 pi. So in order to be able to do that, I'm just going to come down here, double click, and I'd like to be able to create a sequence. So I'm going to type in SEQ to be able to get a sequence. Now, I've got a list sequence here. It's going to be start, end, and count. Let's use that one, okay? There's another sequence that we could have used, but this one actually works really, really well. So remember that a cycle, one cycle is from 0 to 2 pi. So what I'd like to be able to do is I'd like to be able to create a list of numbers that goes from minimum 0 to 2 pi. So the start is obviously going to be, it says null, that means 0, right? The end should be 2 pi. Now, in order to do this, if I double clicked and typed in pi, there is a pi node, and I can use the multiplication and so forth. But to make things a little bit cleaner and a little bit easier, we're going to use the math expression. And we're going to actually come back to this a little bit as well later on. So if you type in math, we're going to get the math expression. And this is going to allow me to be able to write any type of math expression I want to use in here. Okay, and there's actually a bunch of tools here to be able to get cosine and so forth. But I'm just going to use this. Now, I said that this needs to be a list that goes from 0 to 2 pi. So that's one cycle. So I'm going to come in here, and actually, I'm not even going to use an input on this one here. I'm just going to type in 2 times, which is the asterisk key, and I'm going to type in pi, pi, right? It automatically knows that's pi. So now if I go and see the number on this, if I click on this node, you're going to see that is 2 times 3.1415, right? Which is 6.28318530. You get the point. So now I've got that. I can plug that in to the end. So right now I've got a sequence that starts at 0, ends at 2 pi, only has 5 points in there. Well, how many points do I need? I need a lot more points because if I look at this, I've subdivided this line into how many points? Well, let's count. No, let's not count. Let's actually take a look at that. That's our density right here. So I know I've got 40 points. So I need to be able to have 40 in this list, in this sequence. I need to have 40 points. So I'm going to take the number of this, plug it into the count. Now, if I take a look at what's coming out of this, I have a list of 40. So let's just bring this up here so we can see this a little bit. 40 values that start at 0 and go all the way to 2 pi. So that's our basis right now. So we've now defined one cycle, and we've got 40 points that we can use these values, pardon me, to be able to run through a cosine function to change the amplitude of these points. So in order for us to be able to now make use of this, this is just giving us 40 values between 0 and 2 pi. I need to plumb these values into the cosine function. So in order to be able to do that, I'm going to double click over here, and we're going to create another math expression. Now this time, I'm going to start using these ports. Now we're going to need to be able to kind of keep things clear here, because we can't change the name of the ports yet. I know that's in the works. So we need to be able to just use what the defaults are here for X, Y, Z, I, J, K, and so forth for being able to put the numbers in here. So remember I said what we need to be able to do is we need to be able to go cosine of 2 pi, right? We need to be able to put in these values between, or like I said, 2 pi is 1 period. So I'm going to take this whole list here and plug it into here, but I'm going to say cosine, and I'm using cosine because cosine of 0 is 1. So it's going to start elevated. If I use sine, it's not going to be any difference. I could shift it, but we'll just use cosine for right now. I'm going to cosine bracket x end bracket. So now it's waiting for what value am I going to plug into x here? Well, I've got a list of values from 0 to 2 pi. I've got 40 of them. Let's plumb that into here. So now, if I adjust my density, it's going to automatically adjust this list. It's going to give me the calculations here. So now if you notice, I've got 19 points now. I just changed that. If I come over here, this is giving me 19 values that are actually going, if I go here, they're going from 1. And notice these are all positive. They're falling, they're falling, they're falling. Then they go below 0. Then they go to -1. And then they're coming back up again. They get close to 0. They don't quite reach 0 here, right? Then they come back up to 1. So I've just done 19 numbers, in this case here, that is one complete cycle of the cosine function. Okay? What I need to now do is I need to be able to change that. So instead of just having these points lie along the plane, I'd like them to now oscillate based off of those values. So some of these I'd like to subtract. Some of them I'd like to add to. So if I went in here and I said, okay, well, these numbers, and everybody here, if you can remember back to high school math, cosine of any number is going to be between 0 and 1, right? It doesn't go above 1. It doesn't go below 1. In order for us to be able to get that higher, what do we need? Amplitude, right? So we need to add another number here to be able to give us a certain value that this is going to then be increased to. So let's say, for example, I want my oscillation to be able to have a 1 meter oscillation, up to 1 meters, right? 1 meter in the positive and 1 meter in the negative direction. So what I need to be able to do is I need to modify this expression to add a multiplier in the front of it that gives me that amplitude. So I'm going to add another port here, which is going to be Y. So if you come down here on X, we click on this. And actually, if I pan up here so I can actually see this. Oh, come on. Let's zoom out here just so I can see it. It's way up there. We want to add a port. So I just clicked on that, and I'm going to say add a port. This is going to be our amplitude. So and I said it's going to be 1 meter. So let's double click here, and I'm going to type in 1,000. Okay, and this is going to be a range input, so we can change this after the fact. So click on there, and I'm going to go in, and I'm going to put this number up to here. Okay, now Y is not being used anywhere. I just got it plumbed into the math expression. So in order for me to use this now, I'm going to type in Y times cosine of X. So now it's taking all these existing numbers and multiplying them by 1,000. So if we look at all the numbers coming in here, now we've got something more meaningful. Now we've got the offset. If you notice, the first one here is actually going to be at 1 meter. So it's going to have an offset of 1 meter, then it's going to go down to 0, it's going to go down to -1 meter, and then it's going to come back up to 1 meter. So now I can adjust this as what that size of that oscillation is. So we need to now take these points and we need to move them. So let's go ahead and we're going to use another move. So I double click here and say, sure, let's move these. Let's plumb these points in. And by default, I've got a default vector here that's happening, right? And that's going to be 10, 10, 10. That's not, and you can kind of see it here. If I zoom in, you can actually see the other points there. Okay. But I want this to go in the Z direction. So let's go ahead and let's say, okay, this is going to go in the Z direction. I'm going to plug this in. Actually, hold on. Let's we're going to use an amplitude. Let's go in and I'm just going to choose an amplitude vector instead. Sorry. I wanted to simplify it. We're going to come down here. We're going to use the amplitude vector. And what this is going to allow us to do is it'll allow us to be able to tell a direction, and it'll also be able to allow us to be able to plug in numbers. Well, the direction I already told you is Z. So I'm just going to, I could have kept that node there. I'm just going to put that in because all that's doing is it's just giving me the direction. The amplitudes for this is going to be all these values coming in here, which is going between 1,000 and negative 1,000. Now, if we plug this in to the vector here, we've got that form coming across there. Now, this, because the fact that everything's being plumbed in, if I increase the density, that wave is going to be there throughout the whole thing, and I can decrease that to be able to get that wave to be whatever I need that wave to be. But all we've done here is we've taken the points which we've dropped down, and now we're just displacing them to be able to create the bottom of our curtain panel. Is everyone's good so far? Getting the thumbs up, getting the thumbs. Awesome. Okay. So now remember, this is one oscillation because I've given this list here to go from 0 to 2 pi, which is one oscillation. In order for me to be able to change the frequency of this, I need to modify this expression right here. So I need to be able to put in a multiplier to any of the values that are going in between here. And that's going to be able to set how many cycles I have. So anything above 1 is going to be more cycles. Anything less than 1 is going to be less cycles. So what I'd like to be able to do is actually, let's go and put in just a slider that's going to go between, I don't know, 1 and 5, let's say, for example. But I need to be able to add another port here. So we're going to add one more port. So click on here, add a port. We're going to plumb this one in, and we're going to go back and rename these nodes here in just a bit. I just want to make sure that we're following the track of thought going through this. On this one here, I'm just going to double click and let's say 5, and I'm going to put this as a range input. And notice I'm typing in 5 as opposed to 5.0 because 5 is going to give me an integer value for the step. If I put in 5.0, the step is going to be 0.1, so I could be a little bit more articulate. I just wanted to point that out as well. In all of this right now, I'm just dealing with integers. So what I'm going to do then is I'm going to plumb this into here now, and Z, I'm going to multiply this. Now, as soon as I do this, watch what's going to happen here in the graph. So I'm going to go X times Z. The oscillations now, I have 5 cycles. 1 goes from there to there, 2, there to there, 3, 4, 5. And because of the fact that this is integer now, so if I wanted 4 cycles, there's 4 cycles, there's 3 cycles, 2 cycles, 1 cycle. What about half a cycle? Well, let's go in here and let's change this. So now the step is going to be 0.1 instead. And if I drag this down, there's 1.3. So you can see now I've got a little bit more control over how that cycle is going to be. So this now allows me to be able to play around with how the oscillations are going to be. This is going to be the magnitude. And I'm actually just going to come in here and I'm just making these up as we go here. I'm just going to say magnitude of, or actually I should say amplitude. Let's go in amplitude of oscillation. Okay. And then for this one right here, this is going to be cycles. Okay. So now that we have that, we've got a very basic setup here. We can now drop, however far that this is going to drop. You're going to see because of the fact that it's based off of those dropped points, it's going to always take those dropped points and then oscillate them. And we're seeing everything right now. So let's go ahead and let's start making this a little bit more useful. So I'm going to go in and take these and drag them out a little bit here to the side so I can see where all my sliders are. I'm going to take these here, move them out here to the side so I can see again where all my sliders are. And let's go ahead and clean this up. So do I need to see this line anymore? No. So if I right click on that, I could say hide, right? And actually here, because I had so many points, I don't really see that that line is hidden anymore, but now it is hidden. All of these points right here, I'm going to keep those available for right now. All of these points here, that's kind of confusing. Let's hide those. So now I can actually see the points that are being generated here. So I've got these points and I have these points. Now what I'd like to be able to do is I'd like to be able to create a surface between them. So all I need to be able to do is interpolate. Now the interpolation between these points, and because of the fact that I'm just dealing with one list here, is going to be fairly straightforward. So I'm just going to go in, double click, type in interpolate. Okay, and this is going to allow me to be able to interpolate a curve. Now I've got one curve that I want to interpolate with these points. So I'm going to plumb these points into here. And now it's hard to be able to see, but there is a line there. Let's actually turn off these points. And you can see now I've got, this is my interpolated line right there. Let's make a copy of that. And all of these, let's plumb those into there. And let's turn these off for right now. So now you can see that we've got the top and the bottom here. We don't see the points anymore. We just see these two lines. Let's loft between them. So if I click here and I type in loft, we're going to loft this surface. And I'd like to be able to put two curves in. Now, you know that you can hold down the shift key and I can plumb both of these into here. I'm going to do it this way just because it's a lot easier. If somebody else got this, they can understand it. And also, which order that I'm putting in there sometimes causes some discrepancies. So I'm going to take this curve, put it in here to curve 1, take this one, put it into curve 2. And now I've got a surface. Okay? So everything that we've done now has been be able to create one baffle. While we're here, just because I do want to be able to get through everything, and like as we start augmenting this, it might take a little bit of time, especially with the Q&A. Let's just go through the entire process of taking what we've done now and bringing it into SketchUp. So what we need to be able to do now is I need to be able to take this surface and have it exported. Now for 3D, there's lots of different ways to be able to export in here. And actually, if we go into under Exporter, okay, we have STL files, we've got step files, OBJs, DXF, and IGES. The OBJ is the one that I'm going to prefer to be able to use in this method. And the reason being is because it's going to give me it's allowing me to be able to choose the density of the mesh and gives me something very easily to work with within SketchUp. So if I go in here and I just click on the OBJ or OBJ exporter, I'm going to come over here and I'm going to plug this in as the geometry right there. Now, let's close this up here. There's our basic graph for one baffle, and we can play around with. Remember here, as I went through, I was very precise on which nodes I turned off. I'm going to now turn all of these off, what I don't want to see in the configurator, because from the configurator, it's going to allow me to be able to access those nodes that I can see and be able to get a final manipulation before I export this out. So if I was going to go in and get rid of all of these here, I'm going to go in, select a window around all of these, right-click, and hide them. Whoops. Let's actually get this one back here. Sorry. I'm going to show that one. Okay. So all these nodes here have been hidden. These ones haven't been hidden, and these ones here haven't been hidden. So if I come now over here to the configurator, I now have, pardon me, I now have all of these that I can play around with to be able to get me what the size and so forth is. Now, I could have put a material on this, but we're not talking about materials. Let's put this out to be 3 meters, just so then that way it's back. And we're now set up, ready to be able to download. Now, before I download, I'm going to come over here to the settings because this is kind of important. By default, the polygon density is going to be coming out as medium. I might want to have this as higher because remember, SketchUp is a polygon, or like it doesn't do surfaces, right? And in order for us to be able to use this in here, I'd like to be able to have enough divisions to be able to get me nice looking smooth curves. So the OBJ exporter allows me to come in here and say I'd like to be able to have a high density for the polygon density. And I'm just going to say apply and download. And then if I go over here, let me just bring this back over here. Sorry, I got all my files. I do have a BeeGraphy presentation. And let's say that everything is as I want it to be here, right? So now I'm going to take this and I'm going to put it into the BeeGraphy presentation here as the high quality OBJ. Go ahead and say save. Saying that's already in there. Yeah, let's go ahead and replace it. Now we have downloaded that. So if I open up SketchUp, coming back into SketchUp, I'd like to take that and import it in here. So I'm just going to go in within SketchUp, import it in. There's the file that I just saved out. Now, it's kind of important to know here as well, and this is getting into a different program here. Under options, depending on what format that you're going to be choosing, it typically want to be able to always look at the options whenever you're importing. I'm just going to accept everything as is, the model units, because remember I said 3 meters, we're in millimeters, so 3,000. So if I said now import this, wait for it to import. There we go. Oh, sorry. Actually, I shouldn't have said model units. That's way bigger than 3 meters. Let's delete that. Sorry, I should have specified meters here in my notes. Let's go in, cancel. Let's go back over here to BeeGraphy. And under, the import. It was the import, right? That I need to be able to go. Import. Come in here. Options. Not model units. I want this to be in millimeters. Okay. So I go ahead and accept that and go ahead and import. This then brings it in as a 3-meter panel. There we go. Okay, so there's our panel. It comes in all faceted, so you can actually see the faceting. Now, there's tools to be able to clean this up. Actually, I'm going to run and fix it on this, which actually cleans this up really nice. There, and now I've got this that I can then use and be able to generate any type of panels. Just come back to here and use this within my SketchUp model, right? And this makes it nice because now the students can go out, they can play around, develop something within BeeGraphy. If it's going to be some sort of an accent wall with some curves on it, if it's going to be a piece of furniture or a reception desk and so forth, they can play around with it, export it, and now they can bring it into here where they can then further, work with it and either use it for a 3D rendering. They can then export it from here into AutoCAD. You've got lots of different options, or bring it into Revit through Formit. There's a lot of convoluted ways to get from one program to another properly so that actually everything works. But everybody understands to this point what we did. Thumbs up. Oh, here, hold on here. I'm seeing some comments, and I apologize. Actually, I've got another window here that was over top of that. Let me just close this. So there may have been questions that I did not see as we were going through. So excuse me on that one. Anthropomorphic curves. Okay, well, we're going to get to that. If we do have time here today, there's a lot of stuff that we can get through. What do you think about Graph Mapper? Yes, and we are going to use the Graph Mapper as well, as opposed to the cosine function. Here, I just wanted to kind of go through the whole process of setting things up. Now we're going to start augmenting it. But let's open it up for questions and answers. Any Q&A? Or not? We can move along. Perfect. Okay, well, let's move along then. Let's go back into here and let's now make this a little bit more complex. So I'm going to get out of the configurator here. And what we're going to do is we're going to come back here to the original line that I did and all these original points. Let's turn all this stuff back on here just so we can actually see it. Show. Okay. So if we went in and what I'm going to do is for this point right here, from this point on, we're going to do something a little bit different. So I'm actually going to hide all of this stuff right here. Okay, so now that we have all of these points, remember coming back to what we did before, we have all of these points. What I'd like to be able to do now is I'd like to be able to create a series of these baffles that are going to go along in depth. So we got the span, we need to be able to have the series. And to better be able to see kind of what's going to be happening here, so for the density, I'm going to drop that down a little bit. So it's going to be easier to be able to see what's going to happen here and how we're going to be manipulating lists as well as we go through and do this. So the added complexity now is I'd like to be able to have an offset for this. And now you could use move. There's a lot of different ways to be able to do this. What I'm going to do is I'm going to use those lines again. And from each one of these points, I'm going to create a line from each one of these points now going in the Y direction. So I'm going to go in here and I'm going to type in line, and we're going to do the start, the vector, and the length, or start, direction, and length here. So I'm going to take all of these points, put them into here. And then for the vector, remember, I want this to go in the Y direction. So I'm going to double click here. We're going to type in Y. Is it okay if I kind of speed things up a little bit? Or I'll try not to speed it up so it's not going to be too slow. Okay. So here I'm just going to put this in as the direction, and then this is going to be the span. Awesome, awesome. So let's put in the span to be, I don't know, 6 meters, right? So I'm going to type in 6 meters here, just so we have something there that we can then put in the span. Now I'm going to do the exact same thing that I did before. I'm going to divide these, but I'm going to use the trick of minusing 1. So if I went back into here, and if I selected these two, I'm just going to take these two nodes, and I'm going to create a copy of them over to here. Let's put this back over to there. Okay, so then I've got my density and then my subtraction here. So this is going to be, instead of density, let's call this the number of panels. So I'm just going to put in number of panels. Okay, so this has got 27 panels like as well that we can choose. So if I went in here and used this to subdivide each one of these lines, I'm going to go to look for my divide and divide by count. I'm going to plumb this curve, or all of these curves in here right now. Whoops. All of these curves, and I'm going to plumb this into there. So now we've got all of these that we can use to be able to develop our panels now going in depth. There is a problem. And if we look at this, and actually, again, for the number of panels, I'm going to put this to be a lot less. And I also don't want that to be 6 meters. I'm going to tighten this up here a little bit. Let's actually put this here to be number of panels. Let's go 5 panels. And let's say that that's going to go over, I don't know, 500. Okay, so we got something a little bit more condensed here to be able to understand the data structure. So now that we have this divide, this, if we look at it and I take a look at all the points that are coming out, you're going to see that this is giving us how many lists? We've got this one here, which is a list of a length of 5. This one here, we have 7 lists. Well, if we look back over here, or sorry, let's go back to in here, just a sec here. We don't have 7 lists. Let me go back and actually scroll down here so we can actually see this. Come here, parameters. How can I get this to show? There we go. All right. Can I move this? Stop sharing. I can move that over here. Can I move that over to the side? There we go. Okay. This has got 27 in this list. Well, what do we have 27 of? We have 27 points going across this way. And in each one of those, we have 5 values that are in there. So this is a list of all of these lines going in the opposite direction of the span. So I need to be able to take this list and make it so that I've got, instead of 27 lists, I only want to be able to have 5 lists that have 27 items in them, not 27 lists that have 5 items in it. Does that make sense? Because I want to be able to then use those points to be able to draw lines or interpolate lines going this way, not that way. So in here, what I need to be able to do is I need to be able to flip this tree. It's actually, it's transforming the matrix. In BeeGraphy, we call it flipping the tree. So if you go in, oh my goodness, trees and birds. It's a good thing we don't have a flip the bird node. But if you come in here, those that understand what flip the bird is, okay, we're going to look for flip tree. Flip. Okay, and we have a flip tree, and that's going to do exactly what we want. So we're going to take this list of lists, which right now, as we can see, it's 27 lists of 5 items. When we plumb that into here, this is now 5 lists of 27 items. So now we transform the data that we can now interpolate those points. So now that we have that, and we have all of these points, what I can do is instead, remember what this one here did. This one moved all of those points down, right? Well, what we can do is we're not taking these anymore. Let's take all of these and move them down. So what I'd like to be able to do is actually, let's open this up here a little bit so we can have some room here to be able to plug this in. Okay, so in this move right now, what I'd like to be able to do is instead of just these, or taking that one, I'd like to take all of these and move them down. So now I'm going to plug that into the geometry. So now all of these now are dropping down. So we've modified it. So instead of just one, all of these are dropping down and they're in the right data structure that we had for the original line. Otherwise, does everyone understand? If it wasn't in this data structure, we'd have all the spans going only 5 points as opposed to the 27, and we wouldn't get them to line up in our original graph. So in this way, now everything is aligned, so everything will modify as we move down. So all I did was just plumb those in, which is the proper data structure. If we go back in here, we're going to notice that now all of those are following the exact same thing. But here's the point. We now have a depth of all of these, but I've got the same oscillation going on each one of them. So what I'd like to be able to do is I'd like to be able to offset that oscillation so that it's going to be different on each one of the panels going down. In order to be able to do that, what I'm going to do is instead of having just a list, in this case here, like remember when we created this sequence right over here, and the count was just however many density points? Well, we've got the density plus however many panels. So all the points that we're going to need now for this function needs to be this density times the number of panels, which is up here. So I'm actually going to bring this over here and bring this over here because I want to be able to use all of these points, not just one line of these points. I want all of these points. So what I'm going to do is I'm going to modify this list right over here, and I'm going to use the multiplication node. So I'm going to go in here. We'll go to multiplication. And I'd like to be able to take what our density is, right? That's how many points are along one of these lines, and multiply that by however many lines we have, which is the number of panels right here. So if I click on that, I'm going to come down here and plug that into there. So now if you notice on here, this is giving us 135 points because there's 135 points that we have to deal with down there. That all makes sense? Awesome, 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 awesome. Okay. So now that we have that, what we need to be able to do is with this number, we're going to plug that into the count on this list. So if I plug that into the count on this list, now we got a ton of these. Actually, if you look in here, right, we have way more points than what we have in each one of these. And you're going to notice that each one of these rows, it's going to use up 27 of those points, but we have 135 points. So we've got like 100 and here, I'm a math major and I'm trying to do math in my head. 135 minus 27, whatever that remainder is, those are all these other points that are just kind of balled up here at the end going at random heights. We don't want that. We want this list, the data structure in this list, not to be one list. We want it to be however many panels, in this case, 5 lists of those numbers. So I need to be able to take this one list and cut it into a part. We need to partition it into 5 lists. And we can do that with the partition node. So now in here, what I'm going to do is I'm going to go and we're going to type in partition. So we want to be able to partition our list. And what this is going to allow us to do is it's going to take a list, and then I can tell it how many items do I want to be able to put in one list. And then how many of the remaining, like, that's basically a pattern. So if I said 3 items, it's going to take the first 3 items, put that into a list. Then it's going to take the next 3 items, put that into a list. Take the next 3 items, put that into a list. So it's partitioning the list into a structure that now is a list of lists. And that's what everything's based on. So I need to be able to put this into 5 lists, right? So if I need to know what the size is, if I was going to divide this entire list, well, the size of those partitions is however many points I have on one of those spans, which is 27 points. So if I go in here, I take this list, this is the one I'm going to partition, And I'm going to go in here, and actually I'm going to do this backwards just so you guys can see how this works. I do want to be able to take our density. Where's our density? Right here. I do want to plug in our density for the partition length. What if I plugged in our number of panels instead? So if I plugged in my number of panels here, well, that did this properly. But now what it's done is it's taken every 5, so taken the first 5 values, put that into a list. So now I've got how many lists here? I have 27 lists of 5 items each. That's not what I want. So instead of the number of panels here, this is actually one of the things, and I have to say, Learnic, that really is fantastic. If I wanted to disconnect that, and you hold down the control key just by clicking on it, I love not having to drag it back to a node. Beautiful. Okay, and what I want to do is I want to put in the density. So I'm going to take this density slider, put that in here to the size. Now what my list is, if we take a look at this, whoops, it is 5 lists of 27 items each. This now matches what my data structure is. So now if I take this and plug it in, instead of this list going into X, plug this list into X, now we have those oscillations spanning over all 5. So now we've got a totally unique, well, when I say unique, it's no longer the same curve going from first, second, third. It's actually, it's taking the whole cosine function and spreading it out across all 5 of those. And because of the fact that this is all based off of my sliders, no matter what parameters I change here, it's automatically going to update. So now that we have that, come back over here. Let's go in and turn this back on. And just so we can kind of see what's happening here. Okay, we got a little bit of an issue here. I think I'm jumping ahead here a little bit too big. Let's just go in here and hide that for a second, because I've got to be able to follow this data along here now. So in our math expression, we then have the amplitude vector coming in here. And if we look at the vector here, or the output here of the amplitude vector, that's exactly what we want. We want 5 lists of 27 amplitude vectors. That's going to go into this move function. But let's see what's happening here with this move function. If we go in the flip tree, I think that this geometry, we should have 5 lists of 27. That's good. And this is coming into this move node, which is exactly what we want. Here's our problem. What are we interpolating? Well, we want to be able to interpolate all of these points. And we also want to be able to interpolate all of these points. This was just this first line. So we need to go back up here, and we need to be able to get all of our points. So that's all of the points there. This is all of the points up here. Okay. So does everyone understand here? Like right now, we're just taking the first, all of these points and plumbing it through. We need to be able to plumb all of these points through. So now for the interpolate, I'm going to take the output of this, and we're going to go in and we're going to put that into here. And then I'd like to be able to take the output of this. So where's our amplitude by vector? We're coming out of here. Let's actually show that. Or sorry, got to go back. Where do we have this coming in? Math expression, cosine, amplitude vector coming into this move, going into the interpolate. Okay, hold on. Where are all of our bottom points? So we have all of this. This list is going into here. There's our top points. This is going into here. Yeah.
One thing you can do, you can actually hover over the viewport on the points. If you can zoom in, probably you will be able to click on one of the points. It's difficult to catch a point, but you may see a hand icon when you, yeah, with points it's difficult. With
okay. Not a worry. So I just want to go back in through this one here. So we got this going, multiplication coming in here. This is going through. It is going through all of the amplitude vectors. I just want to see here. Got that. That should be coming into the vector in here. The geometry from this. Why do we not see any geometry on this move? Okay. Apologize. And this is one of the things that it does happen. It's not updating. And what I'm going to do here is I'm going to go back out and I have to come back in. I've had this happen before where you're clicking on the nodes and they're not updating, they're not highlighting it, or I'm adding a node and it's not allowing me to be able to highlight or add that node in there. Okay, now it's allowing me. So you noticed before when I was clicking on this, it wasn't highlighting, and that kind of threw me for a loop. So we're good now. Everything's good. So here's the move. I'm going to take all of these ones here. I'm just going to hide those so we can actually see these. This is what we want to be able to run through the interpolation down here. So this one here, if I show this and I show this, okay, and actually let's hide everything else back here because we don't need to see any of this now. Okay. So in here, we have our top lines and we have our bottom lines here. We can then loft between them, and now we have our panels basically allowing us to be able to have however many panels that we want to be able to have in this section right here. So if we wanted to, let's just actually put in a material on this really quick. Apply material, take this, going into here, do a color, and we'll put something in here and like that. No, yellow's by default. Let's put in green. There we go. Okay. So now you can see that we have these panels, and as we go into the configurator, so if I went back into here and we exported this, we can export this out, and everything now works that we can now have as many panels as we want. We can dictate how far that those are going to go. Whoops. We can dictate how far they're going to go. We can dictate the span on them and so forth. Okay. So in this case here, the amplitude of the oscillation, if we wanted to have more amplitude in there, if we wanted to be able to have more density, right, to be able to get a smoother curve, we can do that. We can define how far that's going to drop. We can define the number of panels. And as well, we want to be able to have, what was our number of panels, and then the range input here, like how far back that those are going to go. There we go. Okay, so in here, as soon as I did that, notice that that's giving me kind of a weird oscillation here, so I can go into the number of cycles, be able to play around with that, and be able to get it a little bit more detailed. Now that this as well, let's just do a quick download in here. Actually, I'm going to take the density down just a little bit, just so it's going to be a little bit quicker. And go back into the download. We're still on the high. I'll say apply and download, and do the same sort of thing in here. Now, some of the things that you're going to find, I'm just going to overwrite this one here as well, is sometimes when you export from one software to another, things kind of get a little bit funky and you have to find workarounds. In this case here, if I wanted to be able to pull these, some of them are going to go in one direction, some of them are going to go in the other direction. But in order to be able to get around that, I'm just going to explode the geometry and then clean it up and then redo it and be able to create the panels. So if I went in here, we're going to take out what we've done. The options should still be the same. No, they're not. We're going to say millimeters, accept, and import.
Chris,
Yeah.
SketchUp doesn't support step, which is BeeGraphy.
When I was doing this, I found the OBJ actually worked the best for the. It does like if you go in, and I don't typically use step. I don't think we got the STLs, but I don't know. Yeah, I don't think step files work in here.
Probably they don't support.
No, because step is more for surfaces. This one here, unfortunately, yeah, like because this is a mesh, and again, I'm dealing with the density, try to be able to make things as smooth as possible. This one worked out to be the best. So if I go in here, I'm just going to explode these really, really quickly. I'm going to run a cleanup on it. Whoops, I shouldn't have clicked away. Just so we can see this a little bit easier. There we go. We'll do this, and then I'm just going to do a quick joint push pull on this. Now, obviously, these are a lot closer, and I haven't really played around a lot with, you know, how I wanted those cycles to look. But I've got the ability to go back and play around to be able to get this to however I want it to be able to look. So that all makes sense, right? Awesome. Okay, well, let's get to the graph mapper. And learn it. We have this till 1:30, right?
I'm in no rush.
Good. So we got another hour or two to be able to go through. So everybody's buckled in. No, I'm just kidding. Let's go and let's add the graph mapper onto this here so we could actually start playing around a little bit now to be able to play with how we want this to actually look. If I go back in, let's close up the configurator. So in here, I'm just going to set this back so it's going to be a little bit faster. Let's say that the number of panels, I'm going to put that back down to 5, and we'll put the range here back down to, let's say, 500. So like half a meter there. Okay. So we have this, and now it seems that they're kind of lining up here. So let's actually just play around with the cycles just to get this looking a little bit neater. Something kind of like that. Okay. So in order for me now to be able to start getting into the graph mapper, let's go into one last thing with list management that we should be able to get a good understanding with in order to be able to create more lists that we can work with. Right now, everything is being dropped down to a unified height. What if this paneling was going to be fabric that's going to be cut and placed along a wall? And what I want to be able to have is I'd like to be able to have the first panel to be short and then have the rest of the panels get progressively longer to fill up that wall. What I'd like to be able to do is I'd like to be able to add incrementally to each one of those lists in the data structure, right? So what I need to be able to do is let's first of all start by just creating a list that we can put as a successive drop from first panel to the next panel to the next panel to the next. So now we've got a problem. If we say that the first is going to remain at whatever the drop height is for the panel. The second one, let's say we want to be able to drop that, let's just say a half a meter. So we want to go 500 down on the next one. The next one, we want that to go down 1,000 from the original drop height. The next one's going to go down 1,500 and so forth. Okay, so what we need to be able to do is we need to be able to incrementally add that to each one of those partitions, each one of those lists. So if I'm doing this, I need to create a new list that's going to have a step value of whatever that value that I want to be able to have the successive drops. And I want it to match the data structure that I have here. So what we're going to do is I'm going to come back up here and we're going to create a sequence. And for the sequence, I could go start and count. That's fine. Okay. And what we're going to do is, actually, no, let's use the other sequence for this one. So actually, I'm going to type in sequence. List sequence right there. Okay, so this one here, we're going to allow it to be able to have a start, however many, and then we can specify the step. So the step, remember, we wanted that to be 500. So let's just put this in as 500 for right now. I'm going to put this in as a range input, and we're going to call this step value. Okay, so I'm going to put that in as what the step is. The count, I want to be however many panels we have. Well, we've got a slider for that, which is right here, number of panels, which just so happens to coincide with the count there. Let's plug that in. So now what we have is we're going to have a list that actually has the 5 items in there going from 0 to 2,000, right? And depending upon, like, if I wanted to up this here to 19 and we look at the list, well, now we've got 19 items that are going up to 9 meters, and I can play around with that. So let's bring this back down to 5 for right now. And on this list sequence, so when we look at this, it's just one list. So what we need to be able to do is we need to be able to take this and make it into a list of lists. Well, that's where the grafting comes in. So we need to be able to graft this list so it creates it from one single list to a list of lists. So if I double click in here and I'm going to say graft tree, we're going to plumb this one into here, and you're going to notice that this one here is a list, one single list. This one now is 5 lists. Each one of those contains 1 item. Well, we're partially there. I'd like this to be 5 lists, but I want each one of those lists to contain 27 items, so it matches my density of each one of the panels. So what I need to be able to do is I need to be able to duplicate data. And in order to be able to do that, we're going to use the duplicate data node. So if I go in here and type in duplicate, or is it repeat data in here? Repeat list. There we go. Okay, so this repeat list is going to allow me to be able to take this list of lists, and it's going to be able to repeat too. So now if you notice, we still have our initial list of lists, which is 5 lists, but now we have 2 in each one of these lists. And if we open that up, you're going to notice it's just duplicating whatever is in that list, however many times we want it to. Well, how many times do we want to duplicate it? Whatever our density is. So if I come back over here and we look for our density, I'm going to take our density from here, and I'm going to plumb that into the repeat list. So now my data structure, let's just close this down. Sorry, I've changed it now to 20. Actually, if you look over here, so my density is actually at 20, not 27. I apologize. So in here, we now have 5 lists that contain 20 items in there. So now if I added this to the original drop value, each one of those are successively going to drop whatever amount is in each one of these lists, because whatever's in each one of these lists is going to be added to the other lists, if that makes sense. So let's take this now, and where we look at our drop, so where's our drop here? Drop is right here. And that right now is going in here, and it's now taking in a number. What if we then take this number and we add this to it, whatever the output of this is? So we need to put in an addition node. I'm going to put the addition node up here for right now. So I'm going to type in addition. And I want to add this value, all of those values in the list of lists. And I'd like to add it to this value right here. So now if you notice, each one here is going to be whatever the original value is. The next one here is going to add 500 to each and every one of those, and so forth. So if I take this, we plug that into the opposite here, we now have this dropping at whatever we have the interval here set at. In this case here, we have our step value to be a 500. Right? So that's good. Now this is a uniform drop, right? What I would like to be able to do is I'd like to be able to maybe have this kind of follow a taper, right? Something that I could define with a cosine function. It's not going to be nice, but how about we define it with the graph mapper to be able to have it so that we have like the first maybe 2 or 3 might be, you know, less of a drop, and then it gets progressively more and more and more as we get closer and closer to the wall. So let's go ahead and do that this time. In order to be able to do that, we're going to need to use the graph mapper. So I'm just going to double click here, and we're going to type in for the graph mapper. And for our purposes here, there's lots of different types of graph mappers that we can use. I'm going to click in here, and we're going to use the Bezier one, right? So this one here is going to allow us to be able to use the shape of this curve, and I can grab these and move them around. And it's basically just, it's a NURBS curve that I can grab these handles and play around with what the shape of this is going to be. Okay, now it's important to understand how this works. For those that don't understand, it's taking an input value, and I can define what that first value is going to be mapped to, what the second value is going to be mapped to. But it's important to note, this is a parametric graph right now. It's actually going to 1. So X and Y represent 0 to 1 in both of these directions. So knowing that, that's where being able to work with parametric design, a lot of students get lost with, especially if I wanted to take a shape and morph it onto another surface. I need to parameterize that surface so that I understand how it's actually going to be mapped onto the surface. And parameterizing just means that I'm taking whatever values that there are for the minimum and the maximum, I'm constraining them between 0 and 1, and then using that, because I understand 0.5 is 50, 0.75 is 75, 1 is 100, and so forth. So what we want to be able to do is I'm going to take values and I'm going to plug them through this graph mapper in order to be able to then remap those numbers to different values. So remember here, we have our values being dropped down by a specific amount. In this case here, this is what our step value is. So it's going down 257. Well, if I took a look at the sequence here, so in our sequence in this list, this is one list with 5 numbers. Now they're going down by equal amounts. What if I took those and put them through the graph mapper? So now that shape of the graph is determining what those values are. So in order to be able to do this, what I need to do is I need to reparameterize or remap these numbers to 0 to 1. That's going to be the easiest way to be able to do this. So if I go in here, I'm going to type in remap numbers. All right, there, remap the numbers. I'm going to take this list of numbers here, Okay, and it needs to know what the source minimum and the source maximum are. Well, there's a node for that called bounds. So if I type in bounds, this will allow me to take this list, and it's going to tell me what the minimum value is in that list and what the maximum value is. Minimum value should be 0, which it is. The maximum value is going to be, in this case here, 1028. So I'm going to plug that into source min and source max. What do I want to map these to? I'd like to map them between 0 and 1. Now, in this case, I'm not going to put in a slider or a number constant. I'm just going to override right here. So I'm going to go back and I'm going to say 0. And then the target maximum here is going to be 1. So now it's taking, notice in here, this list goes from 0 to 1028. And the percentage between each one of those is now being mapped into here, 0, 0.25, 0.5, 0.75, 0.1. And it's now between 0 and 1, which is what this graph now is going to represent. I could have changed these values, but this makes things a lot easier for somebody who hasn't worked on my graph. If I'm going to give it to them, they can actually see, okay, well, I'm parameterizing that, so I can use this graph as is, and then I'll remap them after I get out of here. So now if you notice in here, what's happening is I'm going to take all these numbers, which go from 0 to 1, and look what's coming out of this. Actually, the best way to be able to see this so we can compare it is I'm just going to bring in a panel here, and I'll bring in a panel here. And then you're going to see, so these objects here, or this list here is 0 to 1. Coming out of there, this now is showing us, okay, well, the first value isn't 0 because 0 is right here. It's being mapped to whatever this is. And if you notice, this in the graph is kind of a little bit above halfway. I'm going to say that's halfway right there. So I'm at 0.635. If I brought this down to 0, well, 0 is being mapped to 0 here. The next number, which is going to be right here, is going to be mapped to this point on the graph, which is going to be 0.435 and so forth, right? So this graph now is actually taking these numbers and it's remapping them to these, which is this shape. Now, it's important to understand what we're going to be doing here. If this is going to be the ceiling and this is going to be our graph, we're taking the distance. This is giving us distances from 0 to where this graph is. We want the opposite. We want what's at the top of this graph down to this point is actually what we want for the shape to work. It will work the other way, but it's not going to take on the shape of the graph. It's going to take the shape of the inverse of the graph, if that makes sense. So now that we have this mapped, here, let me just delete these panels so we've got this. What I would like to be able to do is I'd like to take all these values, and remember, I want to be able to get these values from the top, right? Not from the bottom. These values are all referenced from the bottom of the graph. I want it from the top of the graph. So I'm going to go into a subtraction node, and I'm going to take these values. These are what I'm going to subtract away from 1. So in here, I'm just going to put in 1. So now you see what's happening here is I'm taking 1 minus each one of those values, and it's giving me the value now from the top of the graph to the actual line on that graph. And that's what we want, okay? So that way, this will mimic what we're going to see here in our preview. So if I did this now, so I've got these as values between 0 and 1 again. I'd like to be able to remap these to something that's going to make sense. So let's say, for example, I would like to be able to map this to, let's say, well, actually here, let's do a remapper here, and we'll work our way through this. So remap numbers. I'd like to take this list of numbers, and again, we need the source minimum and the source maximum. Well, I'm going to use the bounds on this, so I'll just say bounds. We'll take this in, so we got the minimum and the maximum, and I can just plug that in here and in there. So now I got the minimum and the maximum, and if I wanted to, I can then put this to be a value between 0, let's put 0, and however much that I would like to be able to have as the total drop. So let's just actually go in here, instead of putting this in, let's put in 1 meter. So this one here, I actually am going to put in a slider of 1,000 in here. Okay, so now it's remapping those 5 numbers that are going to go between 0 and up to 1,000, okay, based off of this shape. And notice how this shape is. We have it starting here, so the number's going to get shorter, meaning the values are going to get shorter based on this graph. then they're going to get longer again, and then they're going to get shorter. And that's exactly what we have here. We have this being longer, it's going to get shorter, then it's going to get longer, then it's going to get shorter again. But the nice thing is that 0 right here, right, that's the highest point of this graph. That actually is going to be what my drop value is going to be. So what I'd like to be able to do is I'd like to be able to take whatever my drop value is that I'm now plugging into there, and I'm going to add these values that I have here from this graph to my drop value for each one of those. And hopefully that makes sense. Okay? But in order for us to be able to do that, we need to take this list and put it in the proper format. Right now, it's a list of 5 items. So what I'm going to do is I'm going to actually go in and I'm going to take this repeat list and let's just grab this. So I got the graph tree, which is what we need, and our repeat list, which is already there set to, is going to the length of our number of panels. Let's just take this and we're going to copy it over to here. There we go. Okay, and we're going to take this list instead, right here, or it's, hold on just a second. Yeah, we want to be able to take this list, and we want the length of that to be this. Oh, wait a second here. Our list, which is, oh, sorry, should be our grafted tree. Sorry, our tree should be grafted there. This should be going into our list. My apologies. And the length of that list needs to be our density. Where's our density? Density. Sorry. There. Sorry, though, Back to the Future reference. If anybody here has watched Back to the Future, instead of saying it's my destiny, it's my density. Sorry, that was just going through my head as we're going through this. Okay, so now we have a list that's in the proper value. So we got each one of these that we want these values added to our drop, right? That's going to give us that shape coming down. Now, for our purposes here, where's our drop values? Let's come back here. I typically like to come back here so I can highlight it and I can actually see where my drop values are coming from. So this is where my drop values are coming from, and we're adding in. This, remember, was our step value that we initially had. Instead, I'd like to, instead of adding in our step value to here, I would like to be able to add in the values coming out of this node right here. So for this addition node right here, we're going to take this and add it into our drop right there. Now, it's kind of hard to see. Let's actually space this out here a little bit so we can actually see it a little bit better. And yeah, it looks like spaghetti. But let's actually take a look at this and make this a little bit more evident. Instead, for our amplitude, let's drop our amplitude down. Okay, and let's increase the number of panels. And we also want to be able to increase the range of this. So let's have this go over, let's say, 5 meters. And the number of panels, let's put that in to be 20 panels, let's say. So now we can actually see that the bottom of our panels here are following that curve, and they are following it because of the fact that we have, whoops, let's zoom in on there. We have done it where we've subtracted from 1, and that top value here is actually what the overall drop value is, but all of these are getting values added or subtracted dependent upon what this graph actually does. In this case here, we don't go into negative. But if I change this and I said, okay, so I want the first ones to be short, and then I want it to get progressively longer towards the back like this, that's going to allow me to do it. Now, that's actually, instead of going over a range here of 5 meters, let's actually put this in to be over 1 meter. There, so then we can actually see this probably a little bit better. So you see there, we now have this number of oscillations that we have, right? We don't have enough oscillations to be able to give us a nice wave in this. So let's actually go back in here and let's actually go to the cycles. Now this is only going up to 10. I have a lot of panels here. I'd like to go more than 10 for this one here. So let's actually bring this up to the maximum being 100. There we go. We'll close that off and let's bring this up so we can get a little bit more variation in there. Seeing all those points, not being able to see everything, let's actually keep the lines, but let's hide everything else here. So let's just go in and do a quick hide on this. there. Those points are here. Let's hide those. There we go. So now we have this that we can then play around with, and we've got all those parameters to be able to play with. So this, we can continue going on, and instead of having the cosine wave, we can do the exact same thing to be able to create more of a complex wave instead of a cosine wave for each one of these panels and play around with those. But that's kind of where I wanted to be able to take it to, just to be able to show you guys, first of all, data structures, constructing the data structures, taking a very simple point and line system and continually embellishing it and coming up with something more and more complex. Just to, like, again, because here we've already gone an hour and a half. That's what I had scheduled for. If we went back in here, I'm just going to show you here. This was a graph that I actually went through and ended up using the same sort of a curve here. As opposed to doing the cosine, I used the graph mapper down here to create more different oscillations for the panels as well. There we go. So that's where we're at. Does anybody have any questions? Let's open it up for questions now. Okay, I'm hearing a cricket, but I can't make out what the question is. No questions. How was that overall? Like, did that all make sense? And did that kind of give you kind of an insight more on being able to create the geometry using the points, manipulating the points, creating lines and so forth? And the reason why I do this is because I said that, like, and actually, let's just see by thumbs up. How many here are Revit users? A lot of Revit users. Yes, and Stella, I have to say that's the bane of my existence with Revit. I don't know how many revisions that they have to make. They still have not taken some of the basic cleanup conditions and made them actually work within Revit. But getting outside of that, if I was going to create any type of an adaptive family or any type of a any type of a parametric form, I'm creating points, and I usually start with an origin, and I'll build up from there and build lines and points and lines and points and lines and points till I get the end shape that I'm looking for. And throughout each one of those times that I break down, I interpolate it with a spline or a polyline. I take that and I'll use that to generate more points. I'll take that to be able to generate more polylines or interpolated. And you can get quite elaborate structures and have some fun being able to play around with it. So.
Looks like we have no questions.
Okay.
I
So-
think we can address the above two questions, which are there, anthropomorphic curves, and the other one is about graph mapper, which you have already used. So, yeah.
Okay, so so if you were to take a look at, like, the one thing that I know, and I've actually learned, I kind of want to speak out of context on this. But if we were to actually take a look at, what Grasshopper, like Grasshopper, you can actually create some of the initial steps. Like, you don't have to create it all from scratch. And I can then take that and I can use that to be able to develop a form. So, like, if I was going to take, like, for example, I don't know, like, I think what you're talking about is like either doing attractors or using images to be able to create the data. Is that what am I interpreting that correctly? I don't know if he's still here or not. But the nice thing about that is that you can start from something and instead of trying to be able to form it all from ground zero, you have the ability to be able to kind of work back and forth. And I'm not sure if that's something that is going to be coming, Lernick, or if that's going to be something that's, because you can use like that again when we're dealing with data and we're dealing with values in a curve is just there. It's fairly straightforward. Values in something like an image or values in something like something that is more graphical. You can look at the values of the lightness and brightness of pixels, and depending upon how bright a pixel is like how large a number could be. How dark it is how small a number could be. So you could actually use images to be able to define perforations in a screen, for example, so that you can have someone's face and put that into a screen and have it perforate to be able to give you the illusion of that person's face. But in terms of a lot of that sort of stuff, it's a lot easier that I've found within Grasshopper, just because of the fact that I can start playing around with some stuff, physically modeling, and then take that as a starting point getting into like Grasshopper, or in that case, like BeeGraphy.
I can see that David, who asked about anthropomorphic curves, is no longer online, so I don't know.
Oh.
You could have clarified.
Oh, okay.
But it's good. I mean,
yeah,
they will be anyways recording and uploading on the YouTube, so others will get to know about it.
Yeah, he can leave his comments under that video that we published.
Yeah.
Awesome. Well, if there really isn't any other questions, I guess I'll leave it with you guys. What to close up?
Yeah. Thanks a lot, Chris.
Oh, my pleasure.
It was very energetic. It's the end of the day on the is it
yes
Eastern Hemisphere?
You guys are you guys are 6 hours beyond where I'm at. So yeah, you guys are coming out like at 7:30 there, right? Yeah, it's awesome. I really appreciate that everybody did come in that came to this. That's awesome. I'm hoping that it was helpful. I'm hoping that it actually
it was quite good, very informative. We have covered lots of things here: the graph mapper, the data trees, grafting, flipping, the math expression, remapping numbers. I hope people were able to follow, and if there was anything that you guys missed, the recording will be available, so you will be able to go through it again at the pace you feel comfortable.
Awesome. Thanks, guys.
Yeah,
I'll go with
thanks.
0.75x on this tutorial.
What's that?
On YouTube, I'll put the speed as 0.75x.
Oh, yeah. Yeah, I apologize. I shouldn't have had a coffee before I started.
No, it was quite energetic, actually. Chris.
Awesome. Well, it's exciting and it's fun.
Yeah.
Like it's just, and I really love doing it and playing around with it, and so yeah, it kind of shows.
I think that a lot got unfolded in this workshop, particularly. I mean, a lot of different nodes that were explored, which haven't been explored in previous workshops. So I think it was really fun exploring these new nodes.
Awesome. Yeah, no, and there's it'd be fun to be able to do another one, like, because if for an application, like, if we were going to do like a reception desk or do a piece of furniture, or probably do something a little bit more different, like with panels or something like that. But I'll talk to you guys about that, and we could do another one that does something a little bit different and can talk about different nodes as well, different approaches. Oh, one of the things actually that's worthwhile to be able to talk about, or just to be able to explain, this is the way that I've kind of broken it down in the points and the lines is because it makes more complicated forms a lot easier if you start breaking them down and taking a look at the data structures. There are way more efficient ways to be able to do this, and using nodes in I don't want to say more clever ways, but it's just like a coder. If you have somebody who's been coding for years, there are certain workarounds and shortcuts that they can use. Same thing here. This one here, I didn't want to take all those shortcuts because that way, as we started augmenting it, we're building from everything that we were doing. But this graph could be easily condensed even further, but it would be a little bit more confusing because it's taking a lot of the steps out of the intermediary steps that we covered today. But just to know that this is just, one way of many ways of being able to do it.
Yeah, I'll be looking forward to the next workshop we do with you. I think it was really cool.
Awesome. Thank you.
Okay, then if we have no more questions, then let's finish this one. Thanks a lot, Chris.
Sounds, you bet. My pleasure.
Thank you, everyone, for joining, and see you in the next workshop.
Yeah,
Awesome.
next
Thanks,
one
everybody.
is on 3rd, I think. Yeah, next one is by Gediminas, and it will be on the 3rd of September.
I'm going to say I'm a huge fan of his. He is fantastic. Everybody here, honestly, his will be fantastic. I highly recommend it. Yeah.
So next week we have 2 workshops. One is on 3rd and the other one is on 7th. So we hope you all will be there. Awesome.
Yeah, see you all there.
Awesome.
Have a good night and good evening.
Bye-bye.
Bye.
Good morning, many people.